All right, folks, it's Bass Action back in action here. In this video, we're going to work through the rest of our 1.1 to 1.3 warm-up. So if you needed a little extra explanation on those problems, here it is for you. On the first problem here, this is a review of something from geometry that you haven't done for a while, and you'll notice I've drawn out a picture for you for it. So this problem is one that I'm certainly more interested in you being able to do instead of just a straightforward midpoint. This is going to have us looking for an end point when we know a midpoint. So if you remember this from your geometry days, great. Otherwise, here's your explanation. So I've drawn a picture of what's happening here. I have one end point that's right here. I have the midpoint that I've drawn in right here. And it's this other end point that I didn't know. So I need to think about, how did I get this midpoint to begin with? And I would have gotten the midpoint by adding the x values and dividing by 2. And adding the y values and dividing by 2. So with this picture, I can easily set up some simple equations. I have an x plus a 1 divided by 2 must have been a -4, and that's this equation right here. Then I simply multiplied both sides by 2 and solved. No big deal. And then I did the same thing with the y. Y plus my -3 over 2 is my -4 right here. And then I just solved. On the next one, we want to write an equation for a line that's perpendicular to a given line and goes through a particular point. So the first thing that we need to do is figure out what is the slope of the given line that we're doing. Now, you could go back to the discussion that I had in our video about our general form and how to find this, or you could rearrange this problem into slope-intercept form, so that you would subtract your 3x and then divide by 2 and be able to see that your slope is a -3/2, which means the perpendicular slope needs to be that opposite reciprocal. Notice the notation I'm using to help us keep track of our work and stay organized. I really want you to be doing that as well. Now that I have a point and a slope, we're going to use our point-slope form. So we're going to say y minus our y coordinate, and we're going to have our x minus our x coordinate, which of course flips to a positive, and then my slope. Then I'm going to distribute my 2/3. Notice 2/3 times 3/2 gives us a 1. Then we can add our 1/3 over and leave it as a nice 4/3. We would not try to convert this to a decimal because it's not a terminating decimal. Furthermore, we would not want to mix a fraction here and a decimal here because that just is kind of weird mathematically. The next thing we're going to look at is just that quick review of using our interval notation, taking it from our algebra days to our new pre-calc notation. So remember, this symbol here, it's because it doesn't have an equals, becomes an open. This one becomes a solid, and we want everything between them. So the open becomes a parentheses, the solid becomes a bracket, and all intervals are written from low to high, so 3 to 9. On the next one, if we were going to draw this picture, we'd say we want everything that is less than the 17. So it's going to be open because that was not inclusive here, and go towards -infinity. So infinity is always a parentheses. My open is going to be a parentheses, but this needs to be written from low to high. So even though we're mentally thinking less than 17, we write the interval from low to high. Similar thing here in number 9. Now we're going to have the inclusive, so it's going to be a solid. It's going to go in the positive direction. The solid's going to become a bracket. Then I'm going to have a parentheses for the infinity, low to high. Solid, open, solid becomes a bracket, open becomes a parentheses, low to high. I've got a greater than, no inclusive, so it's open. Open become parentheses, infinity is always parentheses, low to high. And then one more, inclusive becomes a bracket, or solid, which will become a bracket, and then has to be low to high. Then the last thing we're going to do is we're going to find the various intercepts. This is a reminder that all intercepts are written as ordered pairs always, always. So the x-intercepts, we're going to find those. We're just looking for where it's intersecting our x-axis, and we can find those in those 3 spots, and we just write those 3 ordered pairs. And then the y-intercepts, notice this is not a function. It's clearly failing our vertical line test. And we're just going to grab those 3 ordered pairs and write those, and then we're all done.